Hey guys, Mr. Wertz here, coming to you with another Algebra 2 video. This time we're taking on translating functions. So sadly guys, I don't have my webcam with me, so we're going to just go ahead and take this one through voice only. So, in this lesson you're going to be learning how to translate a function and then record it in function notation. We're learning this because translations on a coordinate grid can be equated to moving a building on a blueprint in design and construction. And you'll know you're successful when you can translate a function like f of x equals x to the second power up 5 units and then record that translation in function notation. So, prerequisites, guys. You need to know what a function is and be comfortable with evaluating and simplifying them. You need to know how to work with the composition of functions. And you need to use how to use the graphing feature of your graphing calculator. In fact, during this entire lesson, I'm going to be supposing that you have your graphing calculator handy and that you are using the calculator in order to create your graphs. That is going to be my assumption of your academic abilities here. I am going to also expect that you know how to access the table feature on your calculator and that you understand coordinate grid rules such as moving in the x direction, moving in the y direction. And then I am also assuming, as I said earlier, that you are using and you have a graphing calculator as I will be in the lesson. So what is a translation? In mathematics, a translation means to move or shift by some amount. A function translation would then mean a move or a shift of a function by some amount. So observe. I can shift a function up, down, left, or right, depending on the commands I give it in function notation. So what I am going to do here is I'm going to take all of these points and I'm going to go ahead and just move them down. Move this one down 1, 2, 3, 4, 5. And, move it down 5. I'm going to move this one down 5. 1, 2, 3, 4, 5. I'm going to move this one down 5. I'm going to move this one down 5. And this one down 5. And then there's 2 points up here. Down 1, 2, 3, 4, 5. And down here as well. So what I have just done, in essence, is I have taken all of the points, all of the coordinates, and moved them down 5. So this is a translation. It's a slide of down 5. So when I do the best that I can here to try to graph this equation, it's pretty tough to do it freehand. When I graph it, you kind of see that the red graph has shifted down to become the black graph. So commands in function notation. When we use function notation, like f of x for a function, we can give the function commands that will translate the function. So, take a look at this notation. F of x, and it's got an arrow pointing to the new function, says f of x plus h, in parentheses, plus k. So, that arrow means maps to. So, in mathematics, when we talk about the word maps to, we are saying this becomes this. So in layman's terms, in plain English, f of x becomes f of, and then whatever the commands are here. It means that it also means we're going to give a command to the function. So the commands over here, x and k, control different movement inside of a function. So vertical translations. If I give a command in function notation that is outside of the function, as is illustrated below, this adjusts the height of the function either vertically up or vertically down. So what is the connection between k and movement of the function? You can see that if k is positive, the graph will shift up, and if k is negative, the graph will shift down. So there are also horizontal translations. If I give a command in function notation that is inside of the function, as illustrated below, this will adjust the location of the function to either the left or the right, depending on what I do. So you would expect to say positive to the right, negative to the left. Well, it's backwards, okay? On the left, if you see f of x plus h, you're going to shift the graph to the left. If you do f of x minus h, it's going to shift the graph to the right. Notice that h controlling horizontal movement, is inside of the function, so it's with the x. The k is outside of the function, so it's not with the x. So what is the connection between h and movement of the function? H controls horizontal movement. So let's try some basic translations. So we're going to go ahead and we're going to graph f of x equals x squared. So I'm going to go ahead and I'm going to take and I'm going to graph it in red. So x squared I know starts at 0. It has 0, 0 as a point, and then it has 1, 1. It has 2, 4. It has 3, 9. So if you want to check that, go ahead and use your graphing calculator in order to check that. But I can tell you that that is completely accurate. And then you'll have negative 1, 1, negative 2, 4, negative 3, 9. Use your graphing calculator and use the table feature to come up with these coordinates yourself. And I'm going to go ahead and do the best that I can to... That didn't turn out well either. All right. Well, I have learned that I am just going to go ahead and... Can I change the... I'm going to use lines, okay? I would suggest that you don't do this, but I cannot seem to graph this right now freehand, so I'm going to use lines just to illustrate to you guys what is supposed to be happening. And then there would be an arrow here, and there would be an arrow past the 9. So I wouldn't graph it myself like that normally in person. I would definitely be using tools to be more precise, but it is pretty difficult to do it on a computer. So please just bear in mind that that's the best that I'm going to get right now. So for this function, f of x equals x squared, it says to translate the graph 2 units up. So what I am going to do here is I'm going to take my stuff, and I'm lucky enough to be able to just go duplicate, and I'm going to be able to drag this graph around. So right now I have this graph starting here, and I'm going to move every single one of those units. I'm going to move them up 2. So I moved it up 1, and I moved it up 2. So you can see that I have performed a translation of moving it up 2. And now if I duplicate it again and start at the original one, I know that it's not so easy when you're doing it by hand, but you kind of get the idea here. So if I go over 1, 2, 3, and 4, I have translated the graph left 4 as well. So now what I want to do is just kind of properties. Can I get them all to be different? There we go. I'm going to do one in blue. We're going to do this one in red. Yeah, let's get this one in red, please. Nope. Orange. There we go. And we'll do this one down here in green. Now red. Red is good. So red was my original one, and you can see the red one is the original. Okay, so I'm going to just write that over here. This was the original, so it's in red. The blue one is, I'm going to change my pen color here. The blue one is this. Excuse me. It is the 4 units left, and the orange one, my goodness, is, so I can't really make orange here, so I'll make red and change the color. So we'll change the color with properties, not sound. Change it to orange to match. All right, so you can see that these are all the different, the original is this color, the different function types of translation. So I've moved it up, I've moved it to the left. So writing and simplifying commands. If we would like to write an equation for our new translated function, we must have some way to do this. Because the function exists on the coordinate grid, it has to have at least some function or equation that will represent it. Fortunately, we can find it simply enough by applying the command to the function mathematically. So take a look. I took the equation, or the function, f of x equals x to the second minus 4. And I've noticed here that this is saying go ahead and take f of x, but take 5 from it. So mathematically, what this is telling me to do here is to go ahead and take 5 away from this function. And here's how I'm going to do it. So f of x equals x squared minus 4. Well, I need to get that out of there because you know what? Instead of f of x, I'm going to be writing x to the second plus 4 minus 5. Parentheses, though. Always use your parentheses. So f of x equals this. So now I'm going to go ahead and combine any like terms or do any distributing that I can. I can't do any distributing, but I can definitely do x to the second, and then 4 minus 5 is negative 1. So in order to represent a graph that has been translated down 5 of x squared plus 4, I would need to use the function x squared minus 1. So I'm going to do some examples for you. Write the new functions for these functions after they have had a translation applied to them. So f of x is equal to 3x minus 2 maps to f of x plus 3, meaning go up 3. So I'm going to take the original function f, and we're going to use this notation here. F with an apostrophe means f prime, or function after translation, so translated function. When you read f apostrophe, you're reading translated function. So translated function f equals, you're going to take the original 3x minus 2, and I'm going to tack on an additional 3. So let me get my highlighter out to show you exactly where that came from. This is going here. So now I just have to combine any like terms, and I definitely see that. So f prime of x equals 3x minus 2. So 3x, and then negative 2 plus 3 is positive 1. So that would be how to translate. That's what a function might look like after you translate it up 3. The next one here, I'm going to just go down and then come back over. Down 8. Okay, so I'm going to take this function, and I need my highlighter again, my trusty highlighter. I'm going to take this function, and I'm going to do exactly what I just did over here up top. Except instead of plus 3, it's going to be minus 8. So it'll be f prime of x. That is very important to do f prime of x. That lets your reader know. It is also something for you to remember that you have translated the function. So f prime of x is equal to negative 5 over 4x plus 2, parentheses around it, because that was substituted for x. And then you have minus 8. So when I simplify, I get f prime of x equals, well, the negative 5 over 4x will not change, thankfully, but 2 take away 8 is negative 6. So I do have my new translated function here. So let's take a look at what would happen if I move some of these functions either right or left. So if I have f of x equals 3x to the second plus 1, and I am told that I need to translate it to this function, f of x minus 2, notice that the minus 2 is inside the parentheses, though. That's how I know it's going to be horizontal, is because it's inside the parentheses. What I'm going to do is take this entire bit, and I'm going to substitute it in for x here. So you get f prime of x equals 3 halves, and then you're going to be putting x minus 2 in instead of x, so it would be x minus 2 plus the 1 on the outside from the original function. So you can absolutely use this in a graphing calculator. You could type this in as you see it. This is graphing calculator approved. Graphing calculator approved. You could totally type it in exactly as it's written up there, and it will correctly move the function. It is best practice for you guys to go ahead and simplify it. So this would be 3 halves times x And then 3 halves times negative 2 would be negative 3 plus 1. So then the new function would be f prime of x equals 3 halves x minus 3 plus 1 is negative 2. So minus 2. So it is best practice for you guys to do this one as well, but this is completely acceptable up here. So this is the best. This is good, and this is best. So now let's see what happens when I want to translate a function left for. So if I plug this in, all right, I get f prime of x equals. Now instead of x squared, okay, I'm going to be replacing all of the x with this. So x plus 4 is going in here. So I'm going to put in parentheses, x plus 4 squared minus 1. Okay, and at this stage of the game, we haven't had much practice at multiplying polynomials, so I don't expect you to go any further than this. If you type that into your graphing calculator, it is what is best. So that is all you need to accomplish here. And it will produce the correct version of the graph on the coordinate grid. So continuing, multiple commands. We can give multiple functions multiple commands by simply stacking them. They all take effect. So if I look at this one, I have f of x equals x to the second mapping to f of x minus 3 and then take away another 3 on the outside. What will this function do? Well, the negative 3 on the inside is going to cause it to shift right 3. And the negative 3 on the outside is going to cause it to go down 3. So if I want to move these commands into the function, what it's going to look like is this. I'm going to do f prime of x equals. And instead of x squared, I'm going to write the x minus 3. So x minus 3 squared. And then I would put minus 3 on the outside to match this. And that's it. We would then be able to graph this, and we would get a nice, perfectly clear view of how that function has been translated. Right 3, down 3. So, I'm going to show you an example of doing all of this. Okay, we're combining everything that I just showed you into a single type of problem. Graph the original function as listed, interpret the command given to the function, and use it to graph the translation and write a new equation for it. So, the function is f of x equals 2x minus 1. You guys should take your graphing calculators and type in y equals into your equation editor 2x minus 1 and graph it. I am super proficient at graphing, and so I don't need to do that, but that's okay if you do. I hope that you'll use your technology appropriately. And then, yep, put a line through it like this. So then you've got arrows on the end. And that's the original, okay? I did the original with black. Now I'm going to do the new one with blue. Or, excuse me, with red. I think red is best. So it says f of x plus 2. So what I'm going to do is take all of these points and I'm going to move them up 2 on the graph. So this one moves off the coordinate grid out the viewing window. This one moves to here. This one moves to here. 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 Found a new y-intercept, by the way. Up to here. Up to here. Up to here. Here. And a point that wasn't previously on the coordinate grid has now become visible. So I first need to use a black line through it. And I'm going to change its properties to be red. So just give me a second. Properties. That is definitely not what I clicked. Interesting. I'm struggling. Well, I can't seem to get this to graph in red, but that's okay. For now, I'll just kind of do this. And I'm going to do that did not turn out well. I'm going to do my best here, sorry, to overwrite the line with my red pen. I got a little off course there. Yep, so I did the best that I could. I apologize. It's really tough to draw because I couldn't seem to turn my line red. So, but you can kind of see what I'm going for here. Now I want to graph the translation and write a new equation for it. I see that I have a new y-intercept right here. Okay, I see it. It is very, very obvious that I have a new y-intercept. So I need to make sure that I have that taken into account in my graph. Did the slope of my graph change? No, it didn't. But you know what? We're just going to do that formulaic approach that we did before. F prime of x equals, we're going to take the original function, 2x minus 1, and add 2 to it. Since it's telling us to take the function, add 2 to it, not add anything to x. So when I am done, I get f prime of x equals 2x plus 1 instead. All right, now I'm going to do it for a graph that is moving to the left or the right, horizontally. So if I go ahead and start my parabola here. So this parabola, and by the time I get any further, that parabola is going to go ahead and have reached the like if I try to go to a new coordinate, that parabola will be off the grid. So did the best that I could. Sorry again, it's a little shaky. But now it says f of x equals x plus 4. That is telling me to go not left. Yeah, it is telling me to go to left 4. Excuse me. So I'm going to take all of those points and I'm going to translate them left 4. So if I'm going to go purple or red again, so we'll do red here. 1, 2, 3, 4. So it's going to go over here. And then I am going to follow the same pattern. So this was moved over 1, 2, 3, 4 points, and this one here was moved 1, 2, 3, 4 points as well. So this will go this way. Oh, these will just end up overlapping, which is okay. Sometimes the points will overlap. And this one will be here, and this one will be here. Okay, so my curve was a lot better this time. So you can see that the black graph has migrated 4 units to the right in accordance with what the translation was telling me to do. So for this one then, I can go ahead and write a new function in function notation of f prime of x equals. And because it's f of x plus 4, like in the parentheses, I have to take the parentheses amount and put it in for x. So it's x plus 4 squared, and then I have minus 2 on the end. So if you were going to type this into your graphing calculator, it would produce the red function as shown there. Okay, and I got another one here because it's really important that we see all types of ones and what they can do here. So graph the original function as listed, interpret the command, give it to the function, and use it to graph the translation, write a new equation for it. So if I start graphing right away, the original function is plus 3, and it's 3 halves. So up 3 over 2. So you can see I'm just working the equation backwards here. And I'm going to take my line because I want to get through this quickly. And it goes off in the distance for forever outside the coordinate grid, outside of our viewing window, excuse me. So now I'm going to go ahead and substitute this into x. That is because that's what it's telling me to do. When it's inside the parentheses, it takes the place of the entire x. So in this other equation, or in my new one, f prime of x, I'm going to have 3 halves x plus 2 plus 3. And you can definitely realize immediately we're going to be moving left 2, but you can definitely type this into your graphing calculator and you'll get the right graph. That's totally fine, but I suggest that you multiply it out. So I get f prime of x equals 3 halves x. 3 halves times 2 is positive 3 plus 3. So my new equation becomes the f prime of x equals 3 over 2x plus 6. So if I move all of my points, if I adjust them in accordance with what I was supposed to do with my new equation, and I'm going to do a dotted line for this one. The dotted is the translated one. You can see that I have moved every point to the left 2. Okay, so you can see that, you can see that I have moved 2, I have moved 2, moved 2, moved 2, moved 2, all the way to the left. And then finally, if you're looking at a graph and you see two functions, it's very likely one of them is a translation. So in this example, this function f of x has already been translated down to f prime of x. So let's record it and write the new function. So the original function is f of x equals x squared plus 3. But the translation was down 1, 2, 3, 4, 5. So the translation was down 5. So f prime of x, essentially what I'm going to need to do here is take away 5 from the original function. So I get f prime of x equals x squared minus 2. And I know this was a long one, guys, but I appreciate you sticking in there with it. Functions have specific actions, can have specific actions applied to them, commands that translate their locations on a coordinate grid. The translation can easily be described in function notation and then simplified to find the new equation of the graph. Interpreting these commands is important to graphing the translated functions and writing the new equation. It is pretty easy to actually just apply the translations if you don't have to do any of the function equation work. Like, it's easy to move a graph left 2. It's easy to move a graph up 5. It's not a super complicated process. If we see a translation on a graph, we can write a new function to describe that movement, like we just did, where I went from x squared plus 3 to x squared minus 2. And that's it for today's video, guys. Thanks for watching, and I'll see you in the next one.